we're now shifting from linear functions to a quadratic function. So quadratic functions are the U-shaped parabola graphs. So we're looking at parabolas in this unit. So there are three forms of a quadratic function. Standard form, which we'll be spending today and a little bit of tomorrow looking at. Vertex form and intercept form. So those are the three forms of a quadratic function. For a quadratic function, your biggest exponent is 2. As I mentioned, the name of a quadratic graph is a parabola. And ax squared plus bx plus c, this is the format in standard form. Ax squared plus bx plus c, a, b, and c would all be numbers. So if you had f of x equals 3x squared plus 4x minus 5, that would mean a equals 3, b equals 4, c equals -5. Being able to identify the coefficients will be important for graphing and eventually solving equations. So let's start looking at the key elements of a graph. So when you have a parabola, the first notable thing about a parabola is something called the vertex. So the vertex is the highest or lowest point of a parabola. Highest or lowest point of the parabola. The vertex has an imaginary vertical line going through it that is called the axis of symmetry. Y-intercept, of course, is where it crosses the y-axis. So those are three of the first things that you can get from a parabola. We can also tell from the function if the graph is going to open up or down. So that's what the a value is for. So with the a value, if a is greater than 0, so in other words, if it's positive, the graph will open up. If a is less than 0, then the graph will open down. So as you can see from the example that's provided to you, this graph is opening up. This dot that I just filled in, that would be your vertex. So your vertex here would be -2, 3. Dotted line is your axis of symmetry. So the axis of symmetry, number 1, I drew it as a dotted line. I don't care what kind of line you use for that. Dotted or solid doesn't make a difference. But also notice that the axis of symmetry is also the x value of the vertex. The axis of symmetry is also the x value of the vertex. So the axis of symmetry should always go through the vertex. And then the y-intercept is where it crosses the y-axis. course, we'll look at how to do all this stuff algebraically. But before we continue, any questions so far on axis of symmetry, vertex, y-intercept, or whether the graph opens up or down? Any questions on just those four parts? All right. If there isn't anything, then we'll keep it on moving. So the next thing is maximum and minimum. So the y-coordinate of the vertex tells you the maximum or minimum value. Well, how do I know if I have a maximum or a minimum? It's based off of the x value, based off of the a value. So I'll scroll back up in a second. If a is positive, that means the graph is going to open up and it has a minimum value. So this first diagram is what something with a minimum value would look like. A is positive, it's going to open up. The vertex would be the lowest point, so the y value of the vertex would be the minimum. If A is negative, then it'll open down, and the vertex will be the maximum. So if you're looking at the graph that was provided as an example, the graph opens up. That means that the vertex is a minimum. And the minimum value is equal to 3. So the minimum value is always the y value of the vertex. If we were dealing with a maximum, it would work the same way. Any questions, max or min? So again, if the question comes up while the instructions take place, don't be afraid to type it in the chat. I can always see them. I got the Chromebook sitting in front of me. So the last part, before we actually do a graph ourselves, is domain and range. Domain for a quadratic function is very, very easy, and it will never change. Negative infinity, positive infinity, all real numbers. So domain, you do not have to worry about because it's never going to change. Not for a quadratic function. The range, however, depends on if the graph opens up or down. So it depends on whether the graph opens up or down. If the graph opens up, then your range goes from the y value of the vertex to positive infinity. That's if the graph opens up. If the graph opens down, then the range starts with negative infinity and then goes to the y value of the vertex. me say that again. The range is dependent upon whether the graph opens up or down. If the graph opens up, then you start with the y value of the vertex. If the graph opens down, then you're starting with negative infinity. So for the example at the top, so for this example, the domain is negative infinity to positive infinity. The range is 3, comma. Any questions, domain and range, before we do a graph ourselves? Any questions, speak now, or keep your peace until later? Of course, if you get stuck on any part or you need to see it again, the video will be uploaded to Google Classroom. That way you can view it as much as you need to. But let's go ahead and do a graph ourselves. So make sure your graphing calculator is nearby. We will be using it. All right, example 1. F of x equals x squared plus 3. First step you should always take. Identify A, B, C. A is the number that sits in front of x squared. B is the number that sits in front of x. C is the number that doesn't have a variable attached to it. So identify those 3 things first. So y-intercept, very, very simple to get. Set x equal to 0, solve for y. That's y equals 0 squared plus 3. So that's 3. So the y-intercept is 0, comma 3. Go ahead and put that on the graph first. Axis of symmetry. So the axis of symmetry has a formula for it. X equals negative b over 2a. That's negative 0 over 2 times 1. 0 divided by 2 is 0. So your axis of symmetry is x equals 0. That's the dotted line. So x equals 0, go to your x-axis, put your dotted line. Or solid line. Again, I personally don't care what version you use. As long as there's a line going through it, I don't care if it's dotted or solid. Vertex. So the vertex is a point. Vertex is an actual point. The x value of the vertex is whatever the axis of symmetry was. AOS means axis of symmetry. Y value is the number you get after you plug in. the axis of symmetry. So you're going to take 0, plug it into the function, and 3. So your vertex is 0, 3. Yes, the vertex in this case matched the y-intercept. That's not going to happen all the time. So clear that from your memory base. It's not going to happen all the time. So the vertex goes in the middle of the table. Pause for a second. Any questions so far? Alright. So now I'm going to show you how to go about getting the table, and we're going to let the graphing calculator help us do that. So I'm going to show this twice. I'm going to show it twice. After the second time, if you still didn't catch it, you can catch it when you look at the video once it's uploaded. Alright, so we need our graphing calculator. So with your graphing calculator, you're going to press y equals to pull up your calculator. Then you type in the function that you want to look at. So it's x squared plus 3. So x squared plus 3. So now you want to get to the table. So you press second and press graph, and your table should pop up. So on your graphing calculator, to get different numbers, you're going to have to use the arrow keys to scroll down or to scroll up so that you can get more numbers. Any questions before we continue? So now we need to fill in our table. 0, 3, that was your vertex. So you need 4 more points. So pick 2 values that are less than the vertex. Pick 2 values that are greater than the vertex. So -2, 7, -1, 4. -2, 7, -1, 4, 1, 4, 2, 7. So which points you pick, I don't care. Ideally, you want to pick points that are going to fit nicely. But you should have 5 points on the graph. So, just to show you again how it goes in the calculator. You go to y equals, you type in the function that you want, x squared plus 3. Press second, press graph, that will pull up your table. That will pull up your table. Then you pull what you want off the table to produce your graph. questions before we finish off this problem? And let's see that. Found the y-intercept, found axis of symmetry, found vertex, did the table. Now we need domain and range. So domain is negative infinity to positive infinity. Range, the graph is opening up, so that means the y value of the vertex comes first, and then infinity. There's our domain and range. There's the end of our graph and our analysis of the graph. Questions, example 1. That's the domain. What was your question? I'm sorry. Yes. I'm here. Go ahead. Hello? Yes, I can hear you.
Oh, sorry, I don't know why I can't hear you. I said that you said it. That's my question. I didn't hear you.
So the domain is negative infinity to positive infinity. That never changes regardless of what kind of function you have.
Okay, so that's what was confusing.
So, yeah, those are infinity signs. So all quadratic functions are negative infinity to positive infinity for the domain. Any other questions? Example 1. All right, example 2. Let's see, can you go back up into the up and down notes? Brooklyn, you'll have to catch those once I've uploaded to Google Classroom. All right, so example 2 is negative x squared minus 4x plus 5. So again, your first step is to identify your A, your B, and your C. And then we do the same thing that we did above. So for your y-intercept, you set the x values equal to 0. Solve for y. That's going to give you y equals 5. So your y-intercept is 0, 5. Next is your axis of symmetry. Remember, AOS means axis of symmetry. X equals negative b over 2a. That's negative parentheses negative 4 over 2 times negative 1. So notice that there is a negative sign already in the formula. You do not have the right to cancel out that negative sign unless you are plugging in another negative number, which we are doing right here. 2 negatives can't sit next to each other. A negative times a negative is positive. 2 times negative 1 is negative 2. That gives you negative 2. So x equals negative 2 is your axis of symmetry. That's your dotted line. vertex. Remember, your vertex is a point. X value is the axis of symmetry. The Y value is what you get after you plug it in. Minus 4 times -2 plus 5. That's negative parentheses 4 minus 4 times -2 plus 5. What I will say here is you need to make sure you do the order of operations correctly. If you mess up the order of operations, you will mess up the vertex. If you mess up the order of operations, you will mess up the vertex. And of course, the vertex is always the middle of your table. Questions before we continue? All right, so let's keep going. So we're going to put the function into the calculator and let it give us the table. So go to our calculator, go to y equals negative x squared minus 4x plus 5. Hit second, graph. So if you notice, -2 comma 9, there's your vertex. 0 comma 5, there's your y-intercept. So you need to pull some more points so that you can make your graph. So I'm going to pull -4, 5, and -3, 8. And -1 comma 8 and 0 comma 5. So notice that my y-intercept is a part of my table. Does the y-intercept have to be a part of the table? No. But you might as well use it. You did find it. So there's your graph. Any questions before we get the domaining range? Alright. So domain is -infinity to +infinity. Remember that never changes. The range. This time the graph is opening down. So since the graph is opening down, you start with -infinity. And then the second number is whatever the y value of the vertex was. The y value of the vertex was 9. So that's -infinity, comma, 9. So we have all of our parts. Any questions on example 2 before we wrap this up?